Okay. Yes. So, yes, it's my talk on Trusteer Rapport. It's the second time I've unfortunately volunteered to do something like this, the first time being 8 years ago at the first 44Con in 2011. And back then, well, the talk didn't actually go down too well. Depends on what side of the fence you happen to fall on. So I spoke at 44Con 2011 and haven't done since. Primarily because of what actually happened after 44Con 2011 and, well, what people said about myself personally. I'm a source code auditor, a reverse engineer. I'm an avid exploit coder and habitual hoarder of said exploits. I very rarely release anything anymore. After 2011, I don't think I released anything ever since then. And I'm also somewhat known for ranting, apparently. And if you look in the top right-hand corner of most of the slides, you'll see quotes. Those aren't taken out of context. They are quotes from people related to Trusteer, sometimes the CEO of Trusteer at the time. Don't think he has anything to do with the company anymore. Or quotes from Trusteer's lawyers to various, media organizations telling them to get rid of stories, basically. So in that case, it was Trusteer's lawyer telling the Times to change their article. So, things I learned about myself as a result of 44Con 2011. Now, there's a caveat to this. These are what people said about me. This isn't what I actually am. Yeah, I'm a liar, apparently. Everything I did in 2011 was a joke, despite the fact that it was provable. I never released any source code for it. So, well, you could argue that, yes, I made it all up, but unfortunately I didn't. I don't understand the difference between practical and theoretical. That was a common comment, particularly from guys at banks who wanted me to lie to reporters to say that what I did wasn't practical, that the exploits didn't exist, and it was all just theory. The next one's actually the worst one by far. Worst by far. I'm anti-Semitic, apparently, because I happen to look at Trusteer code, and that makes me evil, basically. I like to use PowerPoint design ideas because I don't really have any design ideas of my own, and I read Paul a little bit too much, which is why I get why I come across as a bit of a troll. So why is this a decent topic? Well, memories are short, unfortunately. Trusteer Rapport is still around, despite my best efforts last time around. Trusteer and IBM are still found in the UK banking sector. They're still being pushed, although nowhere near as bad as they once were. After the buyout, they kind of dropped off a little bit. But there are bad examples, Santander being one of the worst. They will constantly pop this box up all the time, even today, basically trying to get people to install this thing. And the issues disclosed in 2011 are quite often still present. The fixes they put into place and claimed that it fixed everything just didn't fix anything. Of course, I never released the exploits or any of the code, so they just fell into disrepair, and nobody else bothered to look, and no follow-ups. So we're here again, unfortunately. Why is this still a decent topic? Well, back then, I did get a lot of rather bad press. Articles such as this were published. They contain nothing but quotes, basically, from Trusteer. It's basically an exercise in advertising. I mean, I even calculated it. There's 681 words, 412 words of which are quotes from the CEO of Trusteer, which is 60.5%. So if you want advertising, the register's the way to go. Yeah, the Daily Mail also took down an article within an hour. This was an email that I sent to a reporter just after 44Con, asking him why the story disappeared. He replied, quite honestly, and said that it disappeared because Trusteer told him it wasn't a problem anymore. So we just delete it. It doesn't have to exist anymore because it's just not true. So, that's the past. The present. Well, unfortunately, this talk should have been longer than it was meant to be. And that's partly my fault. You see, in mid to late 2018, I decided to go trolling or fishing with IBM and Trusteer and see how they would react to a couple of bugs in Mac OS X implementation. So I baited a hook and promptly casted it. The issue itself was known back in 2011, was actually put in by Trusteer in an attempt to fix the original bugs, but in trying to fix the original problems, they created more. But of course, I never released the source, so I waited 7 years, as it was, and decided, well, I'll see how IBM and Trusteer will respond to these bugs. The CVE itself is 2018-1984 plus 1. It's actually 1985. It's an issue in the macOS kernel driver component permitting arbitrary code execution. And it was 8 years old at the time of disclosure. Yeah, so that's the IBM bug report there. The actual issue itself was pretty simple. It was a user assignedness bug in a length parameter. So you have the conditional move here is signed. And of course, if you specify a negative length, you basically get an arbitrary length mem copy into kernel land, and thus facilitating arbitrary code execution. That was the bug that was disclosed. So the bug was disclosed on the 15th of August. The vulnerability details were dumped public just before Christmas 2018 without a patch, because IBM just were simply taking too long. They were given 90 days, and they were given an extra 60 days, and blah, blah, blah. And they just kept saying, no, 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 no. Anyway, the patch was finally made available by IBM and Trusteer in and around February of this year. I can't know exactly when. I simply wasn't told. So the problem with this is that the issue itself could have been solved with a 9-byte patch. Now, this is why I was effectively fishing and trolling to see what IBM would actually do, because I knew that the bug itself could be patched really quickly and really easily. However, there was a caveat to it. You see, to access this bug, you had to figure out how to bypass Trusteer's protections, to bypass its checks, to make sure that the person calling the driver is actually Trusteer or IBM code. And in giving them the exploit, I'd let them know that I'd figured out how to bypass it. So I wanted to see how they would react. Would they fix the bug and ignore the rest? Or would they try and fix the rest? Well, it turned out that they were up to something more substantial. Instead of just fixing the bug, they actually removed it entirely. They destroyed everything, just took the driver out completely, which is pretty much exactly what I wanted them to do in 2011, but it took them 8 years to do it, despite the bug was actually known for 8 years. Perhaps if I'd sent it earlier, a lot less people would be infected with Trusteer Rapport right about now. But, that's something I should have done. Right. So why would IBM Trusteer remove the entire driver? Well, as I said, they had to have known that, given my exploit, that there were other bugs as well. So in dropping this bug and getting IBM to destroy and completely remove the driver, I'd accidentally killed about 3 or 4 other bugs that I was planning to release at the same time. But I had no idea that IBM would actually take such a course of action. I honestly thought that they just do what Trusteer usually do the simplest patch, say everything's fine, back to normal. In case you're wondering what the actual bypass was, it was a cryptographic signature, which is there. That's how you bypass it. You create a section with a segment, and the contents have to be validate _check _data. That's a cryptographic signature, according to Trusteer Rapport. Yeah, and it is Crown Sterling approved, that one is, because that's really good crypto, you have to say. Excellent crypto. But other bugs existed. As I said, there were at least 3 or 4 other more. These were all code execs. In validating the binary, they had to parse it. And of course, if you're going to walk the macro headers and segments, you've got to at least do it correctly. And Trusteer couldn't do that. So there were at least 2 or 3 arbitrary code execution bugs in the parsing of the binaries, all of which were unfortunately rendered useless in the IBM purge when they removed all the kernel driver from OS X. So now we're pretty much left with the Windows version. Still, why is this a decent topic? Well, Trusteer were bought out for $1 billion 2 years after 2011, 44Con 2011, which is reason enough in and of itself, because IBM, I don't know what they actually paid $1 billion for. They can't have paid $1 billion for the program, because if they did, and there are any IBM buyers in the room, I've got a bridge to sell you, because that's just not worth anything like that, you know. Yeah. I did find out how he made his money, and unfortunately, it's legal. Yeah. So the goal originally was to just show all the bugs, but unfortunately, since IBM killed the macOS stuff, I'm left with another goal. Since they're willing to kill the macOS stuff, are they willing to kill the Windows stuff? So can I get them to delete everything? With any luck, I will. So, Windows. Since the macOS version is pretty much neutered from a PrivS standpoint, there's nothing left anymore. It's just a bunch of userland programs that inject code into browsers, you know, just like any other piece of malware. So it's no point in really looking at it. We're left with the Windows. And we didn't give this much attention in 44Con 2011. I mostly looked at the OS X, which is something that Trusteer used an awful lot in their press campaigns to talk it down way back when, 8 years ago. They would often say that the bugs were macOS only, and that only affects 355,000 people. You know, the Windows version would affect far more, but of course he didn't say anything about the Windows version. Well, let's talk about the Windows version. And furthermore, I do have to say that this is actually the CEO of Trusteer, one of his quotes to me in an email where he claimed that I'd released fully baked, exploit code to the public. I've never released any code to the public, ever, for any of this. But seemingly he thought that I did. So there are several drivers in Rapport in the current version. The most useful is this one, Rapport, and I don't know how to say that second word, Eagle, which apparently, according to Wikipedia, is ancient Greek for dazzling light. There's some hidden meaning there somewhere, probably. But anyway. And it is absolutely racked with backdoors. You can spot them blatantly. They're everywhere. The ones in red are the places you will find CVEs or ways to get around permissions in the Windows kernel. The boxes highlighted in blue are arbitrary registry access APIs that you can call. Some of these red boxes actually have multiple bugs in them. So multiple joys. There are so many CVEs you couldn't count. There's probably more CVEs in this line here than there are people in the room, if you actually took the time to go through them. But there is actually a problem to access these bugs. Rapport know, or must know, that they're not meant to be doing the things that they are doing, or permitting their own programs to do. So they try and restrict it, much like they did on macOS. But it's an implementation that is bypassable, and we'll go through it now. That implementation is contained in that big yellow box, by the way. Right, so when did I actually look at this? Well, I was looking at it during the evenings, about when the World Cup started, late last year. I did try for about 2 months to get 2 Windows VMs to talk to each other with a kernel debugger and gave up. I've never actually used a kernel debugger, much to my detriment. I probably should actually learn how to use one, but never have. I then stepped through the entire implementation instruction by instruction, which took about 2.5 weeks, and then promptly neglected to document a single thing. So I promptly forgot everything, absolutely everything, in trying to bypass this thing, and kind of bypassed it just by accident, really. You'll probably figure out almost instantly how to do it. None of this stuff is very difficult at all. Right. So the short of it is quite simple. It requires a match against a specific DLL in the distribution. So to access the kernel driver, you have to have come from a specific DLL. And the name is pretty simple. It's rapportutil.dll or rapportutil_x64.dll if you happen to be 64-bit. And it requires the file to match the cryptographic signature. So it actually validates that the file hasn't been manipulated on the disk. So you can't just edit the file and then, make the calls. It validates that. The long of it is somewhat more complex, as these things often are. First, I'd really like to give some, props to the guy who actually wrote this code in the big yellow box, because it is actually very, very good code. I had no idea that you could ever do any of the things that this guy actually implemented. His code is pretty much impeccable. I can find no way to make it crash at all. About the only way you can make it crash is if you happen to be running a version of Windows that the Rapport don't know about, because if you happen to try and load their driver on a version of Windows that doesn't exactly match a list of known build numbers, you'll instantly get a bug check for so your machine will be completely useless, because every time you reboot it, it'll just bug check again. But in trying to access and bypass the protections, this guy's code, impeccable. As far as I can see anyway. Anyone find any bugs in it? Yeah, I can't really look. It grabs all manner of pointers from opaque data structures. The guy who wrote this is obviously a Windows kernel reverse engineer. He knows what he's doing, and he really knows opaque data structures. Either that, or he sits with a debugger all day long. Because he really knows the internals of these data structures. Each is validated extensively. So all these pointers to everywhere, they're all validated. Absolutely everything is checked. No crashes, as far as I can see. The implementation performs two phases. Firstly, it obtains pointers to the K process and the K thread structures for the calling process. These are opaque Windows kernel data structures. I won't really go into the structure of these. You can pull the definitions from just about anywhere. It computes the location of the PEB and the TEB for the calling process and the calling thread, and then performs magic, essentially. It proceeds to read from the calling thread its entire stack and validate the call chain all the way back. So it pulls trap frame, reads EBP, EIP, and hardware ESP values, and then validates that the stack looks valid. That is, it's growing the right way, the pointers point to valid memory, you can read the memory, the values of stored EIP, EBP for different stack levels of the stack are all valid, they all point to userland code, it's all correct. It does this for the top 5 stacks of the calling process. Only the top 5. And then matches the stack frame saved EIP values to DLLs. So it tries to look up for each saved, for the top 5 stack frames. It looks up the address, the EIP value, and tries to match it to a known DLL that's loaded into that process's memory space. The paths of each of these DLLs is then matched. So it tries to match the top 2, at least, to Windows System 32. The reason simply there is the top 2 stack frames have to be Windows System 32, kernel 32.dll. The top 2 entries must be kernel 32.dll. One of the top 5 must not be in Windows System 32 or Windows Syswound 64. And this one must be rapportutil.dll or rapportutil.x64.dll. That is the match. At that point, if it gets that far, if you're actually rapportutil.dll, it will read, parse the DLL and validate the cryptographic signature. In jest, to try and get around this, I did a couple of tests. What if I actually made the call from rapportutil.dll? So the original idea in 2011 was just to load the library. So we load the library and just resolve a symbol, make a call through their own code. Because it came from their code, it'll pass. Unfortunately, that doesn't work. It doesn't work because they figured out after 2011 they should pack their library and pack it in such a way that I can't be bothered to figure out. So I didn't bother to decrypt it. And so I can't resolve symbols and I can't make calls through their binary. But there is potentially another way. What if I loaded the library, changed the first page to read, write, execute, dropped a shim or a trampoline in and made a call to the driver from there? And that one works, unfortunately. Well, fortunately for me. Caveats for the implementation. Well, it caches the DLLs that call to the driver in a doubly linked list. This is a simple DOS if anyone ever wanted to try it. It caches these on the kernel heap persistently. So if you wanted to test this, you could knock up a simple POC, just make multiple calls, create a DLL, load it, make a call to the driver from the DLL, unload the DLL, rename it, reload it, etc., etc., fill up the memory, and persistently drop every box that Rapport happened to run on until the user uninstalls it, which would be the best course of action. So I created a function for this called Rapport device I/O control. It's identical to device I/O control, except the first argument is a return address. I'll get to how exactly you use this in a few minutes. Right. Creating your shim or your trampoline, it's pretty simple. In fact, it only takes about 10, maybe 12 instructions to do it. We just create a dummy stack frame, push the arguments and jump. The only problem is the return value from device I/O control must point to rapportutil.dll. So we can't do this in C. We have to write our own small little piece of assembler to do it. And there we have it for 32-bit x86. This is the exact code that you'll find in all of these exploits that calls through to the driver. So we have the first argument being the return address. And the return address here must point to the following 2 bytes, 5DC3 or pop ret pair. And the return address points into rapportutil.dll memory space. So effectively, what we do is we load the library rapportutil into our own program, change the first page to read, write, execute, change the first 2 bytes to 5DC3, and then call rapport device I/O control with ret address being the base address of the library we just loaded. And Rapport will believe that we are Rapport. The same thing for 64-bit, except we actually require a little bit more in the return. But aside from that, it's identical, pretty much. And we have access granted at that point. Now, pretty much all the flaws after this revolve around system call functions with a previous mode of kernel mode and thus bypassing permissions checks. The image there was stolen from James Forshaw, I believe, at Google Project Zero. But these issues have been known for many years. This is the best, if you're looking for details on how you actually exploit these bugs, this link here is by far the best and simplest explanation I've ever found. It was written by Microsoft way back when they actually thought of security bugs as reliability flaws. So that the title of this document is actually Common Driver Reliability Issues, despite the fact that the only thing it details is security bugs. But there you go. As I said, the explanations on MSDN for these type of flaws are a bit esoteric, but if you really want to understand them, if you pull that link while it still exists, there are very simple explanations as to what this stuff does. Well, these type of bugs I've seen before. I saw one in 2010 pulling apart disk encryption drivers. To give you an idea of why I will pose the question, are IBM intentionally backdooring their machines? I've seen these bugs before, and they are intentional. They're usually put in for one purpose, and that is to subvert permissions, the security of the system, because you want to do something that you're not meant to be able to do. In this case, it was a kernel driver written by, I don't know if there are any old people in the room that remember 8-bit days. There was a guy called Sean Hollingworth who wrote a full disk encryption driver. It's still in sale today. He used to work for Gremlin Graphics, writing games for Spectrum's, for the old Spectrum ZX machines. He's a bit of a fall from grace, because back then he was writing games that I used to play as a kid. Now he's backdooring machines so he can read license files. And he doesn't need to run his code with permissions when he just backdoors the kernel and just reads any file he likes. So these things are, if you ask me, they are intentional. If you look at the actual structure of the code in the Rapport driver, it's written very much like an API. You know, make one call, you get one thing done. So you make a call to delete a file, you delete the file. The CVEs themselves that you would actually find if you look at this driver, well, there are no numbers as yet, because these aren't actually reported. So I'll give as much detail as I can, but I prefer not to give out, weaponized information. I got moaned at for that last time, so I'd rather not get moaned at again. The first one is straight up arbitrary code execution in a stack-based overflow. Device IO control number there, 222048. It's an unguarded mem copy from whatever you put in here. It gets copied to a stack, straight overflow. The same IO octal code. Well, this one is one of the worst backdoors. This is an arbitrary file rename and move. You give it a file name, it will move it or rename it to any place you like. Now, you can think about how you might abuse that. You're a guest or, some unprivileged user, and you don't like a file in a particular place, even though it's owned by system. Not a problem. Just ask Rapport to do it for you, and it will oblige. If you want to delete a file, you can delete a file. Now, I've left that unopened there because I couldn't be bothered to figure out what the actual device IO octal code for it is, but it's right next to the file rename. You can't miss it. So you can delete any file you like. Remember, these are just a flavor. If you want the rest, or to enumerate them completely, just download IDA free, pull down Rapport, throw the binary at it. Simple. It'll take you less than 10 minutes. You can also write to arbitrary files, but you have to have the handle open. Unfortunately, as far as I know, there's no way to have Trusteer Rapport open a file for you. So you can't just open, any file you like and read it or write to it. Unfortunately, there may be a way to do that with a race condition, but I haven't had the time to look at it. And another useful one is an arbitrary process kill. Now, this one I've actually used in one of the demos. So one thing I actually wanted to do was to get Trusteer Rapport to kill itself and then backdoor itself. On the same system, using its own driver. So I actually use this one. So you can kill any arbitrary process that you happen to want to kill, who's running as any user. And of course, there's plenty more. You just have to look for them. So let's see if we can actually get this thing to work. I had an awful lot of problems getting these things to work earlier. Right. So you can see that. This is Trusteer Rapport installed yesterday on a Windows 7 host, 32-bit, either 32-bit or 64-bit, it doesn't really matter. It was updated as of yesterday, so these are the latest and greatest updates, as far as I'm aware, anyway. Right, so first and foremost, we will show, so here we have Rapport Management Service.exe running a system. Process ID 3504. We can terminate that 3504, and that should kill it. Should, yes. There we go, dead. So that's process termination. Obviously, it gets a little bit better than that. I can show you how you might, oh, hang on, that's the wrong one. Where is it? Oh, start. Thank you very much. Okay. Right. So if we actually wanted to backdoor the program, one way to do it would be to kill the process and then rename the executable Rapport Management Service to somewhere else. So we have the directory over here. I can't delete that file or anything without elevating privileges anyway. Now let's see if this will actually work. This is where it starts to get sketchy. There's a race condition here. Yeah, there's a race condition. So we've killed it, but not moved it. So it's still there, unfortunately. Oh, start it again. Nope. Ugh. Yeah, anyway. One of the problems with my exploit is it assumes that Rapport service, management service will be running, so it tries to kill it first, and sometimes it doesn't respawn. You have to do it manually. Oh, it doesn't seem to want to work now. Oh, hang on. I might be copying it to a place where it already exists. Yeah, that's likely what it is. Go away. C /. Yeah, it's already there. Ugh. Delete. Right. And of course it's not running now, so I have to start it again. And now it works. There we go. So at this point, we've killed Rapport, its management service, which is running a system, using its own driver, and then used its very own driver to move the binary completely out of the way into a temporary folder for us. At that point, you can just drop in another piece of code into the same exploit to move whatever binary you happen to want to execute when it respawns back into the same directory, and away you go. And that's using nothing but functionality that is there and is only meant to be used if you're IBM Rapport. If you figure out, as I say, if you figure out how to identify yourself as Rapport, then you can use all of these function calls directly. So, is it intentional? Well, IBM did the following. They implemented functionality that they knew would subvert permissions of the operating system. They distributed it around the world using Trusteer Rapport, and then they hid it behind a firewall that you can only access if you happen to be their code. Personally, I'd say that that kind of implies intentionality. You're using this functionality in your own program, you just don't want other people to use it. But it's there, and it's on every single Windows installation that's currently existing. And the banks are still pushing it. And it doesn't take more than a few hours to figure out how to subvert the protections, and the API is simple to figure out. All these exploits are trivial to write. Well, other things, I'll dump all the emails that I got from Trusteer after the first 44Con 2011, which are just for true comedic value. If anybody remembers back then, some of the things that were said were just hilarious. And another lesson learned, I did spend about a week trying to figure out if the code I was looking at was actually the code I was meant to be looking at. Digital signatures and, validating that the module is actually Rapport or not. And then I just so happened to remember that I'd installed it on a 32-bit machine, put it on a 64, pulled the binaries off, and it turns out that Trusteer left in all the debug symbols. So you can just, all the debug messages, all the symbols, everything. So it's all there for you to look at if you happen to want to reverse it. I encourage you to look at the 64-bit version, not the 32. Okay. Does anyone have any questions? At the bottom, that's a bit of a troll. I was considering removing it. The quote at the top there, that one actually was a suggestion from a Trusteer lawyer to the Times reporter. I don't know if you remember back in 2011, the Times wrote an article about all the bugs in the first version. The Trusteer reporter thought it useful or pertinent to try and get the Times to write a new article. And the article he wanted publishing was basically an interview between Trusteer and Banks. So you can imagine what would have been said there. But suffice to say, the article was never printed, thankfully. Okay, that's the end.